Hello, this is the bonus video on independent events, which returns to the first question that was asked in the very first video, which was, if you have mutually exclusive events, are they independent always, dependent always, or just sometimes depending on the circumstance? And I wonder whether you have thought about that and whether you're ready to commit to one of those three options. It is one of those three, remember. So I've encapsulated it here. Are mutually exclusive events independent? And here is the answer. Drum roll, please. Brrr. Answer is no, they are not. And by no, I mean mutually exclusive events are never independent. In other words, mutually exclusive events are always dependent on each other, which may feel counterintuitive, but I've got a couple of ways of looking at it. And the first thing I'm going to do is look at it mathematically. Mathematically, we've got two formulas that deal with the probability of A intersect B. So the probability of A intersect B for mutually exclusive events, you might recall, thinking about the Venn diagram, that for mutually exclusive events, they are separate, no intersection. We know that the intersection is 0, okay? But for independence, we know that the probability of A intersect B is equal to the probability of A multiplied by the probability of B. Now think about that for a second. If they were mutually exclusive and independent, then we would be saying that the probability of A times the probability of B equals 0. Okay? I'm going to go M.E for mutually exclusive and independent. Then probability of A, probability of B would be equal to 0, which doesn't make sense. And I'm going to leave it there for the writing, but I'm going to talk to it just for a moment. Why doesn't it make sense? Well, null factor law. Probability of A times the probability of B equals 0 implies that probability of A or the probability of B or both is equal to 0. One of those probabilities at least has to be equal to 0. And if one of those probabilities is 0, that means the event itself is impossible, because that's the very definition of a probability being equal to 0, right? So it's nonsensical. It doesn't make sense to talk about the independence or mutual exclusivity of an event that actually is impossible. So the whole thing collapses at that point. Because the probability of A must be a value and the probability of B must be another value, then you're always going to get a non-zero value by multiplying them together. Conceptually, I like this. This is the bit I find a little bit more tricky, and I hope I get it right in this video. Imagine you've got two events, A and B, that are mutually exclusive. Okay, so they're mutually exclusive. For A, to exist, B, or to occur is probably a better word to use. For A to occur, B must not. For B to occur, A must not. Yeah? So let's choose let's choose flipping a coin. So if A is the event that a head is flipped and B is the event that a tail is flipped, then for a head to have occurred, it must not have been a tail. And for a tail to have occurred, it must not have been a head. Okay? So the occurrence of one event automatically cancels out the other event. So therefore, I'll just keep it zoomed out now. Do you know the triangle of dots means therefore? I hope you do. So therefore, they are dependent on each other in a weird way. It feels like a toxic relationship, doesn't it? So they're dependent on each other because A's occurrence is dependent on B not having occurred, and B's occurrence is dependent on A not having occurred. And so there is an innate dependence on each other in order for the events to occur. Okay, I risk over-egging it if I keep on explaining it. I think it's a really important concept to get hold of, the difference between mutually exclusive and independent. I hope this video helps make it right in your head. I'm happy to have more discussions with you one-on-one if that's of assistance. And I'll leave this video and independent events here.